In this episode, we are going to look at what happens after a technician thinks a system may be infected and needs to decide what to do next. For beginners, this part of security can feel stressful because there is a strong temptation to reach for the first cleanup tool you know and hope it fixes everything. The problem is that different infections behave in different ways, and a response that works well for one situation may be weak, risky, or completely wrong for another. A computer that is showing a few annoying pop-ups is not in the same condition as a laptop that will not boot, a machine that keeps reinstalling the same malware, or a system where files are suddenly locked by ransomware. The best response starts with understanding that detection, removal, and prevention are connected but not identical. A technician needs to notice what kind of threat may be present, judge how stable the system still is, and then choose a method that fits both the infection and the condition of the device. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. A good first step is understanding the difference between seeing signs of trouble and actually confirming what kind of trouble is present. Users often report symptoms such as slow performance, redirects in the browser, fake alerts, missing tools, blocked security software, or files behaving strangely. Those symptoms matter, but they do not always point to one single answer right away. A slow computer could have malware, but it could also have too many background apps, low storage, a bad update, or failing hardware. A technician should take the warning signs seriously without rushing straight to the most dramatic conclusion. Detection means gathering enough evidence to make a reasonable judgment about what is happening. That might include noticing visible symptoms, checking what security tools are reporting, paying attention to recent downloads or user activity, and looking at whether the system is still stable enough to respond normally. The point is to learn what kind of problem you are dealing with before choosing a cleanup method, because good detection leads to better decisions. Anti-malware tools are a major part of detection and removal, and beginners should see them as important tools rather than as magic answers. These tools help scan files, memory, and system activity for known malicious patterns, suspicious behavior, or signs that something harmful is operating on the device. They are useful because they can find problems faster than a person can by guessing from symptoms alone, and they can often remove or isolate threats more safely than manual tinkering. At the same time, a scan result should be understood in context. One clean scan does not prove the system is perfectly safe, and one alert does not automatically explain every strange thing the user is seeing. Anti-malware tools work best when the technician uses them as part of a larger thought process. If the system is stable, connected, and responsive, those tools may be the best first step. If the machine is heavily compromised, unable to run security tools properly, or showing signs of deeper damage, then the technician may need a different approach instead of trusting a normal scan to solve everything. Quarantine is one of the most useful ideas for beginners to understand because it gives the technician a middle path between ignoring a threat and deleting something too quickly. When a suspicious file or program is quarantined, it is moved into a restricted state so it cannot keep running or interacting with the rest of the system in the normal way. This matters because sometimes a file looks dangerous enough to isolate right away, but the system or technician may still need a controlled chance to verify what happened before final removal. Quarantine helps reduce risk while keeping the cleanup process organized. It also protects against a common beginner mistake, which is trying to delete things by hand just because they look strange. That approach can create more confusion and may even damage legitimate files if the technician guesses wrong. Quarantine is useful because it gives the system breathing room. It contains the suspected threat, limits further harm, and allows the next decision to be made more carefully instead of under pressure. Containment matters beyond quarantine too, because the condition of the system should shape the response from the very beginning. If a device is obviously infected and still connected to a network, the technician should remember that the problem may not stay on that one machine. Some threats spread, some contact outside systems, and some try to steal data while they are still active. That means a stable but suspicious device may need to be separated from normal connectivity before deeper work begins. Beginners do not need to think like incident commanders to understand this point. They just need to see that an infected system can still be doing harm while it sits there turned on and connected. Matching the response to the threat means asking whether the danger is mostly local, mostly tied to one file, mostly affecting the user experience, or actively putting other systems and data at risk. The more active the threat seems, the more important it becomes to contain the system before focusing on cleanup. Safe mode is another response option that makes more sense once you connect it to the condition of the system. In normal operation, many services, applications, and startup items load automatically, which can include malware or unwanted software that is trying to keep control of the device. Safe mode starts Windows with a more limited set of components, which can make it easier to work on a machine that keeps getting interrupted by malicious processes or unstable software. For a beginner, the key point is not that safe mode is always required. The key point is that it can help when the infection is interfering with normal scanning, cleanup, or system use. If the computer runs normally and security tools can scan it cleanly, safe mode may not be necessary. But if the malware keeps relaunching, blocks tools, or causes crashes during normal startup, then a more limited environment can make removal more practical. Safe mode is useful because it changes the working conditions, and sometimes better working conditions are exactly what cleanup requires. It is also important to understand that not every infection needs the same level of response. A browser packed with unwanted extensions, aggressive ads, and redirects may still be a real security problem, but the response may be more straightforward than the response to a deeper system compromise. In a lighter case, the technician may focus on scanning, quarantining, removing the unwanted program, cleaning up the browser, and checking for any remaining signs of trouble. That does not mean the threat should be treated casually. It means the system may still be healthy enough for a normal cleanup process to work well. On the other hand, if the infection is blocking updates, disabling security tools, altering startup behavior, or showing signs that it has dug more deeply into the operating system, the technician should not pretend it is just a nuisance. Matching the response to the threat means recognizing when a basic cleanup is probably enough and when the symptoms suggest that the problem is deeper, more persistent, or more harmful than a few visible annoyances. Ransomware is a good example of why response choices have to fit the type of infection. When files are locked, when access is denied, or when the screen is demanding payment, the situation is no longer just about removing one bad file and moving on. The main harm may already have happened, and the technician has to think about preserving what can still be protected and planning recovery carefully. In that kind of case, the focus shifts from ordinary cleanup toward containment, damage control, and restoration. A quick scan may still have value, but it does not undo encrypted files by itself. Beginners should understand that ransomware changes the support problem. The issue is no longer just whether malicious software is present. The issue is whether the user's data, the system's usability, and possibly the wider environment have already been damaged. That is why a technician should not treat every malware event like a routine cleanup. Some threats mainly cause nuisance, while others change the system or data in ways that demand a more serious recovery path. Spyware and keylogging threats show a different reason why the response has to match the threat. If the main danger is quiet data theft rather than obvious system damage, then the technician has to think about exposure as well as removal. Even after the malware is removed, the problem may not really be over if account credentials, private information, or other sensitive details were already captured. This means the cleanup process may need to be followed by steps such as password changes, account review, and closer attention to what information may have been entered on the device while it was compromised. For a beginner, this is an important lesson because it shows that removal is not always the full answer. A machine can look better after a scan and still carry the consequences of what happened before the scan. Matching the response to the threat means asking what kind of harm the malware was built to cause. If it was built to steal, then the technician needs to think beyond the machine itself and consider what else may now be at risk. System restoration becomes especially important when malware cleanup is not enough to return the machine to a trustworthy state. Sometimes a threat damages system files, changes startup behavior, breaks applications, or leaves the computer so unstable that ordinary use still feels unsafe even after obvious malicious items are removed. In those cases, restoration helps the technician move from partial cleanup toward a more reliable operating condition. For beginners, restoration should be understood as a way to recover system health rather than as a shortcut used in every situation. If the infection was limited and the device is working normally after cleaning, restoration may not be needed. But if the machine remains unstable, missing features, or acting in ways that suggest deeper changes, then restoration becomes a practical way to roll back or rebuild trust in the system. The important idea is that removal and recovery are not the same thing. A threat can be gone while the system is still damaged, and a technician needs to notice that difference instead of stopping too soon. There are also times when the condition of the system tells you that cleaning is no longer the best main plan. A machine that cannot boot properly, cannot run trusted tools, keeps getting reinfected, or shows signs of major corruption may no longer be a good candidate for ordinary removal steps alone. In those cases, restoration from a known good state, or even a more complete rebuild, may be the safer answer. Beginners sometimes feel that choosing a bigger recovery step means they failed to remove the malware correctly, but that is the wrong way to think about it. The goal is not to prove that every infection can be cleaned neatly with a scan. The goal is to return the system to safe and usable condition with reasonable confidence. If the operating system is badly damaged or trust in the machine is too low, then trying endless cleanup attempts can waste time and still leave risk behind. Matching the response to the threat also means being honest about when cleanup has reached its limit. Prevention habits matter because the best malware response is the one that never becomes necessary in the first place. That does not mean prevention is perfect, and it does not mean users or technicians can avoid every bad event. It means many infections take advantage of familiar weaknesses such as outdated systems, risky downloads, untrusted email attachments, weak account habits, unsafe web behavior, or security tools that are ignored or disabled. A technician should understand prevention as daily discipline rather than as one giant security action. Regular updates, careful handling of links and downloads, strong passwords, limited privileges, safe use of removable media, and healthy skepticism toward unexpected files all reduce the number of chances malware gets to succeed. Prevention is part of matching the response to the threat because repeated infections often happen where everyday habits keep leaving the same door open. Cleaning a device without fixing those habits is like drying a floor while the leak is still running. Anti-malware tools also fit into prevention, not just cleanup. Keeping those tools active, current, and properly configured gives the system a better chance to detect threats before they dig in deeply. Beginners should remember that prevention tools do not replace judgment, but they do make judgment more effective by adding automated help. A technician who understands prevention will not wait for a machine to become obviously broken before caring about protection. Instead, that technician sees protection as something that should already be in place before the trouble starts. The same is true for backups and recovery planning. Backups are not removal tools, but they are part of prevention in the wider sense because they reduce the damage caused by a bad event, especially one involving ransomware or severe corruption. Prevention habits work best when they are quiet, regular, and consistent. They may not feel dramatic day to day, but they often make the difference between a small incident and a major one. Another important beginner lesson is that cleanup should be calm and deliberate, not driven by panic. Users may be frightened, embarrassed, or impatient when they realize something is wrong, and they may want the fastest possible fix. The technician's job is to slow the situation down enough to make good choices. That means paying attention to symptoms, using anti-malware tools thoughtfully, isolating suspicious items through quarantine when appropriate, using safe mode when normal startup gets in the way, and choosing restoration when the system can no longer be trusted. It also means explaining that different threats call for different responses. A technician should not promise that every infection has one simple answer, because that is not how real support works. What builds confidence is not pretending every situation is easy. What builds confidence is showing that the response is being chosen for a reason, and that the reason matches the kind of threat and the condition of the system. As we close, the main idea is simple but very important. There is no single cleanup method that fits every malware problem. Anti-malware tools help with detection and removal. Quarantine helps contain suspicious items safely. Safe mode can make cleanup easier when malware interferes with normal operation, and restoration helps recover a system that remains damaged or untrustworthy after the threat is removed. Prevention habits matter because they reduce the chance that the same problems will keep returning. Most of all, the technician has to match the response to what the malware is doing and to how healthy the system still is. A light infection on a stable machine may respond well to normal scanning and cleanup. A deeper compromise, a data-stealing threat, or a ransomware event may call for containment, recovery steps, and much more caution. When beginners understand that difference, they stop looking for one magic fix and start making smarter support decisions based on the real situation in front of them.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.